Topic for today is identifying angles, pairs of angles as well. You've heard a lot of these terms before, so we won't spend a lot of time with it. Complementary angles, that is when we have two angles that add up to a sum of 90 degrees. If we take a look at the chart down here or the diagram, angle ABC and angle CBD, we consider those to be adjacent angles because, again, those angles are next to one another. And notice the sum of those two angles do indeed add up to 90 degrees. How do I remember complementary is 90? Well, if you take a test and you score 90%, that's fairly good. That's probably good enough to deserve a compliment. So 90 degrees, complementary angles. The other main one that we work with is supplementary angles. That's when we take two angles and the sum of those two angles add up to 180. How do we remember that? Or how do I remember? Supplementary starts with the letter S. Notice, what is this form? Well, we can either call it a straight angle or a straight line. So S and S, straight angle, supplementary. But again, adds up to 180. You probably don't need to write all of this down, just complementary, supplementary. A lot of you really don't even need that. Find the angles complementary to angle KLM if the measure of angle KLN is 90 degrees. So they give you some of the information in the diagram itself. Some of the information is given to you in the directions. Saxon loves to do that. They just won't always give you the information here. They make you go back and read at it. So this is what's given in the diagram. JLM is right. KLN is 90. On your own, I want to see if you can come up with the measure of KLM. Oh, sorry, not the measure, but the actual angles. My apologies. I thought we were looking for angles. You know, if we look at the angles that are complementary to KLM, means we want to identify the angle that together forms that right angle. So there it is. My apologies. If we go to B, again, not finding the measure, but instead just identify the angle that is supplementary with DGF. We actually have two answers here, just like we did back in part A. First angle that we could look at, if we look at this DGF, would be this one here. So we should say angle EGD. And the other one could be that one, right? Angle CGF could also represent a supplementary angle that would make a straight line with it. It's adjacent to it, they share that common side, and together they form that straight line. A couple of theorems for today. If two angles are complementary to the same angle, or two congruent angles, then they are congruent. Two complementary angles to the same angle or two congruent angles, then they are congruent. Same idea with supplementary angles. So if we go back to 6-1, angle J and angle K are complementary. And angle J.
Excuse me, Mr. Dorr, would you allow Kendra to come to the office?
Yep.
Okay.
So again, if angle J and K are complementary and J and M are complementary, what do we know would be true about K and M? They're not complementary, but they would be equal or congruent. And that's what they're getting at here. Same thing if they're supplementary. You know, if we say that they're supplementary and this pair is supplementary, then those two have to be equal. Here's the example I was thinking of. Here we are actually looking for the measures X and Y. So let's start with the measure of X. Its value, Tanner.
35 degrees.
Yeah. Notice we have this angle here that's 90 degrees. And now it's a little bit more obvious that we do have those complementary angles between X and 55. Therefore, X is going to be 35 degrees. How about Y now? Sean? 50? You know, again, you can say that this is a right angle here. This angle over here is 40, so 90 and 40 gets us to 130. Remaining degrees that we have left in the straight angle is 50. Therefore, Y must be 50. Okay. Really good test question. Really good homework question as well. Two angles in the same plane with a common vertex and a common side, but no common interior points. Those are our adjacent angles that we've been working with. Next one, a pair of adjacent angles whose non-common sides are opposite rays. This is called a linear pair. And a linear pair is basically a synonym for supplementary angles. This was one of those that I felt we were a little redundant in how we defined it. Because a linear pair, again, is no more than two angles that share a common side, but together the degrees add up to 180 degrees. It's supplementary, hence the reason we call it a linear pair, a pair of angles that make a line. Adjacent angles, however, can be any two angles that share a common side that add up to any given measure. So basically a linear pair is a specific type of adjacent pair. Linear has to be 180. Adjacent angles do not have to add up to any particular amount. They could add up to 30, they could add up to 47. They could add up to 159, as long as they share the common side. So we've talked about complementary, supplementary, 90, 80 specifically. This is your example of adjacent, sharing a common side. These angle measures can be whatever they want. And now we have our linear pair, which is strictly a straight line. 6-3 linear pair theorem. If two angles form a linear pair, then they are supplementary. And this is the theorem that ties a linear pair together with the supplementary angles. If two angles form a linear pair, they're supplementary. Again, maybe a little overkill. They love to ask this question. Identify two sets of adjacent angles in one linear pair. Let's start with two sets of adjacent angles. What I would do is just start by identifying an angle. Let's go A, F, B. If I give you AFB, what would be another angle that would be adjacent to it? Mason?
DFE.
Yeah. Let's trace these two angles. If we trace AFB and then we trace DFB, do they share a common side? Yes. Do we care what the angle measures add up to? No. Let's come up with one more angle pair that's adjacent. I'm going to start by giving you angle CFD. What would you tell me would be adjacent to it?
DFB.
Would have I been okay by saying AFC? No, I wouldn't have. Okay. How about AFD? Yes. Starting to see it? As long as they share that common side, you're fine. CFD, DFE, common side, we're good. Linear pair. Two angles that form a straight line. Again, I'll give you the first one. Let's go with angle AFD again. Sean? Are there any other angles that we could put with this one? No. Because again, linear is the more specific one. They have to add up to 180. This was the only option that we had if I gave you this one. Now there are other options available if I don't give you the first one. We could have said AFB. And if we did that, you would have said BFE and so forth. Sometimes there are multiple examples available to you, sometimes there's not. Last theorem from this lesson. Vertical angles. If we have two lines that are going to intersect at a point, we automatically create these things called vertical angles. Another term that we like to use in math to represent vertical angles are opposite angles. Most students prefer to hear opposite angles because opposite makes more sense to them. If we looked at that simple diagram, A and B would be considered vertical or opposite, whichever way you want to prefer. C and D would be considered opposite as well. And what this theorem is stating is that if we identify vertical angles, we know that they have to be congruent. It's a very basic concept that we've worked with. That's the definition of it. The non-adjacent angles formed by two intersecting lines, vertical angles. So let's go ahead and take a look at example 4. Again, being Saxon, it's not just going to be straightforward. They're not just giving you the angle measures anymore, like 70 or 120, but instead we got to deal with these expressions. They want us to determine the values of x and y. We'll start with these two angles, 1 and 2. What do we know is true about them? Equal. Therefore, what do we want to do with those expressions? Set them equal to each other. If those angles are going to be equal to one another, we know that x minus 5, that expression needs to be equal to x plus 30. You will be doing a lot of that in homework if you haven't picked up on it already. On your own, go ahead and solve for y. Last one. Final answer that we come up with, Taslin? 98.